All right, here's my walkthrough of slides 4 and 5 from lesson 10.1.1. In this slide 4, they want us to create a circle with two non-parallel chords. And we learned earlier what a chord is. It is just a connection or a straight line connecting 2 points through the inside of a circle. So we're going to create two of these chords that are non-parallel to each other. And then we are going to try to find a strategy to find the center of the circle just using the two non-parallel chords and our knowledge of construction. Okay, a lot of this ties into what we were doing earlier with this idea of folding maybe this circle and creating a crease that becomes a perpendicular bisector to the chord. All right, and that's going to be my idea and my strategy for finding the center of the circle is to create a perpendicular bisector by creating a crease or a hypothetical crease, and then doing another one for the other chord. So that's my strategy. I'm going to try to do it on the E tool. First, we create the circle with the two non-parallel chords. So here is one chord, and then we'll put another one here. And I believe it tells me to hide the center as well, because that's what we're trying to find to see, is it going to go through that center point? Well, like I said, my strategy is to create two perpendicular bisectors to these chords as if I was folding the circle in half. Okay, so the first one, just using my knowledge of constructions on how to create perpendicular bisectors, here is one to that chord. And I'm going to hide the circles, and I'm going to leave that there. Now I'm going to build another one to this chord, another perpendicular bisector to this chord. And I hope to say that that intersection point, where these two perpendicular bisectors intersect, will be the center of my circle. And I can check that by using a circle, starting at this point, and drawing it out, and these circles would match up perfectly. So that is definitely the center of my circle, and it is all about creating these perpendicular bisectors to these chords, as if you fold one in half and then folded another in half. Okay? Now we can move on to slide 5, and it's going to be kind of a continuation to this idea of using a crease or a perpendicular bisector here and evaluating. So imagine I again fold this right here down the center, so almost like a diameter to this circle. And it doesn't exactly go through, so I'll try to do a better one. We'll go here to here and then down. Okay. So it says, again, folding as a crease, and that would create a perpendicular bisector here. So this distance that was once 8 is now split in half, where this is 4 and this is 4. Okay, because perpendicular bisector, not only is it creating a 90-degree angle right here, it also splits that length in half. Now I also know this distance from Z to W, because W is a point on the circle, Z is the center. If you go from the center out to the circle, that's a radius, and it tells me the radius is 5 units. So if I'm looking at what I just drew here, I have a right triangle with a hypotenuse of 5, a length of 4, and I can find this missing length by using the Pythagorean theorem. Or even possibly, you can just say that I know this length is 3 because of the Pythagorean triple 3, 4, 5. Okay? If not, again, you could say that you have a squared, which could be 4 squared, plus b squared equals 5 squared, because that's a squared plus b squared equals c squared. That is 16 plus b squared equals 25. That is b squared then equals 9. And then if I actually square rooted both sides, I would see that it was in fact 3 right here. Okay? And that is kind of my walkthrough for those slides 4 and slides 5. A lot of it is tied to this idea that is actually talked about in part B, where you fold the crease and it creates, and when you fold A onto B, it creates this crease that's a diameter, honestly, and that diameter is cutting that chord perfectly in half, and that was a huge part of the entire lesson. Any more questions on any lesson, always feel free to reach out and ask.